What's going on, Joe? Well, there you go. Joe, I know you're not taking the AP stat test, but do you have any questions today? Oh, goodness. Okay, well, there you go then. Well, Joe, the purpose of this stream is my AP stat kids are taking their test at 1 o'clock. No, 2 o'clock today. 1 o'clock. I could try, Paige. Um, Students have offered, to pay me money in the past, but oh man, are you nervous, or is it more of a is it a scared nervous, or is it more of a anticipation nervous? Oh, Joe, they've offered me money to take the test for them. Don't be nervous. No, specifically, is it just a fear of, oh my gosh, I'm gonna fail? Is it a fear of I'm gonna forget everything? Oh, come on. I can tell you every story that I've ever heard and that I've experienced in terms of um, people being absolutely fearful that they're going to fail, and then they're telling me that they're going to fail, and then lo and behold, they end up passing. You know. Oh, you're okay. You're copying the notes now. I have that PDF, and again, I'll put the PDF link in the description of the video. So if you refresh it in a moment, I'll have the PDF. Hold on, PDF of key concepts and formulas. Let me save that. There we go. So if you refresh the stream, in the description should be the link to that PDF that I put in. John, it's okay if you don't have a graphing calculator. There are various things you can do, as I've talked about in my videos. I'm also putting a link to Matt Bogner's website in the description and in the chat. Matt Bogner's website is pretty fantastic. He is a professor at the University of Iowa. I've exchanged emails with him. But he has the binomial distribution, the geometric distribution. He has inference for mu, which could be z or t. If you click either one, you'll have an option for putting in the population standard deviation or not. He has inference for p, which is the one proportion or two proportion test. He has all of that on that link that I just sent you guys. It's really fantastic. It's one of the better interfaces that I've ever seen in terms of calculating those things. But from what I've heard and what I've read, there shouldn't be any intense calculations. Um, a lot of it is going to be based on a lot of it's going to be based on your verbiage, I should say, how you choose to word things, what key concepts you can pull out of problems, what conclusions can you reach based on calculations that were done for you, what type of calculation would be neat, it's things like that. It's two free response questions. Two. And they're going to be pretty intense. But thankfully, they are not going to be doing chi-squared. And because obviously we didn't cover that, and I'm assuming they don't think anyone else covered that. Or maybe if they did, they're crazy. And it is going to not have hypothesis testing for linear regression. Those are the two main concepts that we did not get to in AP Stat. And that's okay because they're not on the test, and we should be good. I'm also going to put into the chat and the description of this video the AP checklist. You've probably already, hopefully, have already seen that. But there is a link to an AP checklist by College Board. I've been sending you guys emails, or forwarding you guys emails for the past several weeks, things that I've gotten from College Board. And hopefully you've taken care of all that information. Fingers crossed. We'll see how it goes. Obviously, there's a lot of things we could do. I'm Googling something right now that could potentially be helpful. What is this? Predictions for the AP Stat exam. Oh, that's just predictions. That's ridiculous. Inferences will look different. Oh, there we go. Okay. Let me send you this link as well. I'm going to post it. I know I'm sending you a ton of links, but this might be helpful. The following link, I'm actually going to read a little bit from. I'm going to read a little bit from just because it could potentially be helpful. Predictions. I'm going to put it in the description as well. 2020 AP Stat. Save that. Okay, good. So let me read something to you. It says, in the past, students could expect to see one question where they constructed and interpreted a confidence interval, and one question where they performed a full significance test. There is no room for this in 2020. Instead, the exam is likely to ask about specific elements within each of these inference procedures. And that's key, such as defining your parameters, naming the proper procedure, checking the assumptions and conditions, proper interpretation of the confidence interval, and proper interpretation of the confidence level. And based on the confidence interval, do we have convincing evidence for a claim? That is stuff that I have emphasized time and time and time again, beyond the calculations. A lot of the time it's been like, well, the calculations will be done on the calculator, and then you have to have the proper conclusion. That's key. For the significance test, writing the proper hypotheses, naming the procedure that you would do, checking the assumptions and conditions, the test statistic, calculating a p-value, more importantly, interpreting the p-value, and making a proper conclusion. I didn't actually check, but I believe most of you, the vast majority of you, almost all of you, watched the You Fool video. Lexi, great question. Okay. Where's my marker? You can all see what I hopefully can write. Boom. Let me zoom up. There we go. You can see what I'm writing here. But her question was, what is the difference between the confidence interval, or interpreting, I'm assuming, right? The wording. Yes, you did say the wording. And the confidence level. So, sorry, I got some, there you go. Okay, so let's just pretend for a moment that we constructed a 95% confidence interval. Let's just pretend that for a moment. So we constructed a 95% confidence interval that produced the following. I'm just going to make these numbers up. It doesn't matter what these numbers are, but let's just say we found it to be like, 0.45 to 0.60 or some junk like that. Now, I don't know what the context for this would be, but that's not the purpose of this. The context would be, I am 95% confident the true proportion of whatever my context is. Again, I don't know what the context is. I'm making this up at the moment. But I'm 95% confident the true proportion is within my interval, or you named the interval, or is within the interval 0.45 to 0.60. But that's what it means to interpret the confidence interval. You're that percent confident that you have captured the true proportion, or if it's means, the true mean. Whereas the confidence level, which in this case, I totally misspelled confidence. I don't know how to spell things. Anyway, the confidence level is 95%, which means if this sample, whatever the sample was to get the confidence interval, if this sample were repeated many times with intervals being calculated, 95% of the intervals would capture the true proportion. That is the proper interpretation of the confidence level. If the sample were repeated many times. So to go back to the confidence interval, there is a sample that is collected. I don't know what that sample is, but that sample has a p-hat. You construct a confidence interval based on the following formula, which produces 0.45 to 0.60. You're 95% confident that the true proportion is within that interval. Whereas confidence level, in this case, we did 95%. It could change depending on what they want. But if that sample were to be repeated many times, meaning I run a sample, and someone else runs a sample, and a third person runs a sample, and 15 other people in California run a sample, trying to capture that true proportion, 95% of the intervals that were created, 95% of them would capture the true proportion, and logically, 5% would not. I go back to the example that we did in class, where I had a little Nerf globe, and we threw it around the room, and we were trying to determine what percent of the globe was covered in water. I believe, according to most estimates, it's like 70 to 75% or some junk like that. I don't know exactly what it is, but it doesn't matter. We calculated a sample p-hat, and I think we got like 50%, which was really low, but it doesn't matter that it was really low. What matters is that that's the sample that we calculated. So we did a confidence interval based on that. And again, I don't remember what that was, what the details were. I know it was like 50%. There's one probability, and I don't know, let's just say it was like 15 out of 30. Just making this up. Maybe those were the exact numbers. And we calculated a 95% confidence level to be 32% to 68%. Meaning, we were 95% confident that the true proportion of water on the planet, or oceans, or whatever, what have you, the Earth is covered, whatever proportion it's covered in water, is within our interval. We were 95% confident of that. What the confidence level means, well, if this sample were repeated like several hundred times, doesn't matter, just many times, 95% of the intervals created would capture the true proportion, and 5% would not. It just so happens that we fell into the 5%. That's what that came down to. What else do you guys got? Throw your questions into the chat. I know I've dropped a bunch of links on you, and if you have questions in regards to the links, I want to talk about the links. If you have questions in regards to the test, let's talk about the test. if you want to unload your fears of taking this test more and more, and I can try to, you know, sit here and reassure you, please, by all means. I'm pretty sure, starting at 2 o'clock, I'll probably just be randomly, you know, driving around Barnegat and yelling statistical information out the window in the hopes that you'll hear it. I think that would be helpful. What do you guys think? I don't know. To be honest, I'll probably be at home. No, but I wish I could be there. Like, not there in the room with you. I would not be allowed in the room with you. Yes, please do that. I would not be allowed to be in the room with you, but in years past, I've tried to hang out as long as I could, because typically you guys would be doing the 3-hour test from noon to 3. Sorry, I just read Lexi's comment. But typically your test would be noon to 3, and I like being there when you guys go into the test. I do. I try to make it a point to make an appearance when you guys are showing up, just to hopefully give you some level of reassurance. But obviously I can't do that now, and that's, I mean, it's hard. I mean, you're the ones taking the test, but obviously it's a little hard for me to not be there with you guys. But I know that you guys will do fine. You know, it's what we've been working for all year, and despite the circumstances that have changed, which is obviously out of everyone's control, I know that you guys are going to rise to the occasion. I know that you will. Not to go on a, you know, a speech. Not that I'm known for my speeches. But yeah, what other questions do you guys have that we can talk about? Again, in the description of this video, if you haven't refreshed it, there's the PDF that I made of key concepts and formulas. There's the link to Matt Bogner's website, which, not that you will definitely have to do this, not that you'll definitely have to do this, but the link to Matt Bogner's website has the binomial, the geometric distribution. It has ways of doing hypothesis testing and confidence intervals with means and proportions. Those are the links on Matt Bogner's website that say inference. There's the AP checklist, which again, I hope you guys went through all that and you have all your information ready to go. And there's that other link to predictions for the AP stat test, which I wanted to go back to that website and see what else they have on there. How to assess full stat scores in 2 questions. One question's about, oh, this is a guy's prediction and stuff like that. How do you find margin of error on the calculator again? Okay. Several ways to go about that. But let me give you the most straightforward way. Paige, I'm assuming you're talking about on a graphing calculator? Or if you had to do it by hand, let's say. Because I have multiple ways of showing you how to do that. Graphing calc. Okay. So, let me actually go back to that silly example that we did with the globe and throwing it around the room. So when we did that, we threw the globe around the room, and let's just say we got 15 out of 30. And we had to calculate a confidence interval for the proportion of water on the planet. Now, the formula that is typically given is something like this. Again, I wrote this down earlier, but I'll write it down again. The p hat plus or minus all this junk. All this junk is the margin of error. That is the margin of error. Now, there's multiple ways of going about this. If you wanted to calculate the margin of error by hand, then you could go about calculating those numbers, basically. But let's just pretend for a moment that you ran it. Didn't I run it before? Yeah, I ran it before. 1 prop z int there are my numbers right there. Hopefully you can see them a little better. There we go. And I calculate it, and it gets me the following interval, which I'll write down as 0.32108 to 0.67892. I'm 95% confident that the true proportion of water on the planet Earth is within this interval, which we know we're wrong, but that's not the point. If we want to calculate a margin of error from this, you got to realize that it would have been 0.50 plus or minus that margin of error. So if you have the interval, you can take those numbers and you could do something like this, 0.67892 minus 0.50. There's your margin of error. Or, I have to run the interval again real quick. Come on, interval, be my friend. 1 prop z int, go back to calculate. You could also do 0.67892 minus 0.32108 and divide it by 2, because that would give you the range of the interval, and then dividing it by 2 would give you the margin of error, which I'll just put that over here. Margin of error is approximately 0.17892. Again, multiple ways of going about this. If you wanted to do it by hand, which again, graphing calculator, non-graphing calculator, whatever, you would have to do this calculation, which for a 95% confidence interval, you would not be capturing the outside 5%, which means there's 2.5% right there. That's a terrible 2.5. Let me write it again. There we go. Which means that this is the 97.5th percentile. So let me do it by hand, kind of by hand with the calculator. I'd have to do inverse norm 0.975, which gives me a z star of 1.96. So you could do 1.96 times the square root of 0.5 over 30, because that was our sample size from before. This should give me the margin of error, which we already know, but I just wanted to see what it gets. 0.5 times 0.5 divided by 30. Oh, wait, I got to multiply. Square root 0.5 times 0.5 divided by 30. Boom! Approximately 0.17892. So there's multiple ways of going about it. If they give you the interval, you simply have to, okay, well, the midpoint's 0.50. In this instance, just subtract these two, it'll give you the margin of error. Or take the range and divide it by 2, it'll give you the margin of error. Or calculate the plus or minus z star times square root, it'll give you the margin of error. Same thing occurs for if you're doing means. Obviously, this is proportions, but the same concept applies to means, where if you were doing means, it would be x bar plus or minus z star times sigma over the square root of n, or x bar plus or minus t star times s over the square root of n. Either way, whatever is after the plus or minus is your margin of error. And if they give you the interval, you could do the exact same thing. Find the range, divide it by 2, or know what your midpoint is, which the midpoint would be your x bar in this case, and just take the upper limit and subtract the x bar, and it gives you the margin of error. Yay! Remember, margin of error is not a mistake. The purpose of margin of error is to calculate the confidence interval. And the confidence interval is attempting to capture the true proportion. So one could say the margin of error, the purpose of a margin of error, is attempting to capture the true proportion, not that there is a mistake. So, what else you guys got? Because we got time, and we don't have to talk about stat. I mean, of course, you'd want to talk about stat, but you want to be relaxed as well, Of course you want to be relaxed. Make sure that everything's settled. Make sure that you're not going to have any distractions. Make sure everything's in working order, your computer and whatnot. All that fun stuff. No, Luke. You did not miss the AP Stat prayer. I was waiting. So I was gonna. I mean, your test isn't until 2. I was actually gonna wait till somewhere in the 1 o'clock range. I might as well do that now. You know what? Let me post it now. I should have done it this morning. Man. Let me find it now. I have a copy of it somewhere, but I like using what I have. Come on, you silly thing. Where's the media on this? Okay. I gotta get past all those pictures. There's the... Oh, yes. Sorry, I just remembered something, so I have to... I have to do something in a minute. Let me save that to my desktop. Save that there. There we go. And I'm going to tweet about it in a moment. I meant to do it a lot sooner. Silly me. So while I'm doing this, again, if you guys have questions, if you have anything else, please let me know, and we'll talk about whatever we need to talk about. Keep those questions in the chat. I'm not looking at the chat right now, just for the sake of argument. I'm trying to type out the AP Stat prayer. AP Stat prayer. Hashtag AP Stat, hashtag AP Statistics, hashtag AP Stat Prayer, hashtag... Anyway, no, I'll leave it there. Tweet. There we go. Oh, sweet, I got questions. Okay. I'll go in order. Lexi says, what's the difference between one prop test and a regular z-test? Now, when you say regular, we got to be specific about that. I'm going to draw my little chart here for a moment. Actually, no, I want a clean sheet of paper for this. Come on, little thing. And believe me, I will get to all of your questions. I will. But let's talk about this. What type of data do you have? Type of data. I know you've seen this before, but this will go into Lexi's question. You either have categorical data, which would be in the form of proportions. And if that were the case, it doesn't matter if you have 1 sample or 2 sample. It does not matter. In that case, you are going to use a z-test or a z-interval. I'm using these interchangeably. If you have quantitative data, if I could spell, quantitative data, which are means, which are things that it makes sense to take an average of, you would then either have the population standard deviation, or you don't have the population standard deviation. If you don't have the population standard deviation, you're going to do T, intervals and tests. If you have the population standard deviation, you're going to go back to Z. So, Lexi, when you ask the question, what is the difference between a one-prop Z and a regular Z, I am assuming you are looking at the graphing calculator in the sense where it says one-prop Z-test and just Z-test. I was hoping you'd respond at that moment, but that's okay. We'll figure it out when the time comes. Let me show you my calculator. Good. Okay. So in the z-test, you can see right here, this is for when you have quantitative data. This is when you have means. This is when you're going to use mu. And when you go into that z-test, notice that it asks for the mu sub 0, which would be your null hypothesis, and it asks for sigma, which is your population standard deviation. If you go into one prop z-test, that is categorical data. Those are proportions. If you go in there, notice that they don't ask for mu, they ask for p. So, do you think this has to be calculator heavy or more concept-based? Definitely concept-based. Just for the sake of argument, I'm going to get back to my students' questions in a moment, but if you look at the links in my description, there is something called Predictions for 2020 AP Stat, and if you go to that link, it will show you what they believe the test will be made up of, and I agree with that website. Anyway, let's see. Maddie, you had a question. Can you show how to show if something is nearly normal for a t-test? Yes, absolutely. How do you show if something's nearly normal? Now, for a t-test, obviously your assumptions and conditions. The regular assumptions and conditions, obviously, it has to be a random sample. For a t-test, the sample does not have to be large enough. It does not have to be large enough. But you have to be able to show if it's random or not, or infer if it's random or not. Independence is definitely a huge thing, because I believe there were 4 major concepts for a t-test. It was independence, it was randomness, it was less than 10% of the population, and nearly normal. Now, there's one of a few ways you can go about doing that. Number one, the problem might say that the data looks normally distributed. Just looks normally distributed. Or they may give you a set of data. They may give you a set of data, and then they may say, okay, well, assumptions, conditions, t-test, blah, blah, blah. Or maybe they want to ask you for that, but it'll be inferred that you have to show those assumptions and conditions. In that case, you can take that data and you can create a histogram. You can either create the histogram by hand, or in most cases, it's easiest to just very quickly get it on the graphing calculator. Just getting rid of that. If you don't have a graphing calculator, then unfortunately you would have to quickly draw something by hand. Oh, there's T distributions. I'll Hunter Henry. I'll talk about his question a little bit. I'm talking about Maddie's question right now. So I don't know. Let me just see if I have a problem here with like some data that I can use to see if it's nearly normal or something like that. Now, obviously, the concept of nearly normal is very subjective. Sometimes it's like, oh yeah, that's clearly nearly normal, and then that nearly normal condition is met. Sometimes it's like, yeah, that does not look normal at all. But it's like, yeah, but it's like, it's close enough, or kind of, In reality, if your distribution is heavily skewed, or like very clearly bimodal, with the 2 peaks being far away from each other, then you have a case to be like, yeah, it's not nearly normal. But for the most part, you could still proceed. You can still proceed with the t-test, even if it's not close enough. Usually they want you to do something like that. Again, I'm trying to find a problem here. I keep finding these like weird 2-sample tests, but come on, you. Okay, this could work. Unless this is a chi-squared one. Nope, it's a t. We'll do this one. So I'm going to throw a bunch of data into my calculator right now based on this question, just to see, because they're doing the differences here. So 241, 247, 217, 255, 255, 178, 219, 233, 256, 295. And then they're doing 212, 257, 210, 257, 256, 180, 226, 224, 241, 282. Okay. So let me look at the first histogram. You turn it on, you look at the histogram, zoom 9 it. Yeah, this one clearly has a gap, but it's nearly normal. I mean, it's close enough. That's the fluffy thing about statistics. As long as it's close enough, you're fine. Let's look at the other one. Change it to L2, zoom 9 it. See, now this one. This one, you could argue that this one is skewed right. you could totally argue that it's skewed right. But it's close enough. That's, again, the fluffy thing about statistics. It's like, okay, is it unimodal? Could you argue that it's somewhat symmetric? As long as it's nearly normal, you're fine. Sketch a little bit, put in like the divider numbers at the bottom, just to show for you to show the grader that you actually like did the calculations or something. But as long as you sketch something like that, you should be fine for the nearly normal condition. Luke, you asked, what do you have to turn the diagnostics on for? If you are running a linear regression, if you are running a linreg right there, ax plus b. Now, I have a bunch of data already in my L1, L2. Now, clearly, the numbers don't really mean anything to me right now. But if I just ran it right now, you can see it gives me a slope and a y-intercept. But if you want to have the r and the r squared, if you want to have the r and the r squared, you got to turn your diagnostics on. Let's go to diagnostics. Come on, diagnostics. Where you go down to D, you turn those diagnostics on, and then if you run that linear regression one more time, you can see r squared and r show up. Remember, r is your correlation coefficient. R determines the strength of the linear association. Hold on, my son is knocking at the door. Hold on. James, I'm live right now with my students. James, you have to wait for mom to come out. My students, buddy, look at me. My students are taking their tests in 45 minutes. I have to talk to them now. Okay, I'm back. My son is playing Pokemon and had a few questions. He's playing Pokemon on the Switch. Back to this. R, I apologize. R is your correlation coefficient. It measures the strength of your correlation. It can only be between -1 and +1. If it's positive, obviously your slope is positive of your regression line, or of your prediction line, I should say. And if it's negative, then your slope is negative. R squared, coefficient of determination. R squared, I'm, in this case, what, 86%? You could say that 86% of the variability of the y variable is accounted for by the linear regression model on the x variable. Again, the context of the problem. So, diagnostics on for linear regression. Do we need to know t distributions? That's a very broad question. Do we need to know t distributions? Not in the sense of having to draw something like that out. There are an infinite number of t distributions, depending on the degrees of freedom. As the degrees of freedom grow larger and larger and larger, the t distribution is approaching that of perfect normality, but unfortunately it'll never get there. For a t distribution, obviously, again, if you're doing inverse t, for example, and you wanted to find out 0.975, which would be for a 95% confidence level, you would have to put in some kind of degrees of freedom. So I don't know, let's just say our sample size was 50, so we put in a 49, and it gets us a t star. Now, if it were a normal distribution, that would be the z star. So it really does depend on the situation. It really, really depends on the situation. But because of the nature of the test this year, I don't believe they're going to have you do many, many calculations in regards to actually, calculate the t star or some junk like that. Like, they would give you enough information to potentially do it without a graphing calculator. I'd say I've done a video in the past actually where if you don't have, inverse T, which the TI-83 calculators do not have, I do have a video on my AP Stat playlist that actually does explain how to get inverse T without having it on the calculator. So, but to Donnie Garrison's question, do you think the test will be calculator heavy or more concept based? Personally, I believe it will be much more concept based. Yeah. So, oh goodness. Can I actually? How do I do? Oh, cool! I already got notifications on this. On the AP Stat prayer. I should share the link to this. Can I embed the tweet? How do I embed the tweet? Copy the code? Copied. I don't want to copy that. Anyway, you should all check out my Twitter. But, here, I'll just, come on, you. There we go. Copy. I'll post it right there. There you go. You can see my Twitter. What other questions do you guys have? Because you got about 45 minutes. I did not intend on this stream going all the way to 2 o'clock. I intended on ending this stream around 1:30-ish to give you guys the time to get set up and settled and whatever else that you need. But I'm here. If you have any questions, if you want to voice your concerns, if you want to just take a moment to scream, to metaphorically scream into a pillow so you get that anguish out of your system. Or if you just want to keep asking questions about AP Stat, please, by all means. I'm right here. Oh, goodness gracious. One thing I will make a note of, if you do have a graphing calculator at home, just in case, make sure you have batteries, extra batteries just kind of sitting by your side. Can you imagine your calculator dying right in the middle of this test when you only have like a limited amount of time to get it done? Nicole, can you explain extrapolation, interpolation? Okay. Extrapolation is dealing with linear regression again. And I'll go into the details of that in a moment. Interpolation, we didn't really get into. We didn't cover that because it wasn't a major concept of AP statistics, the interpolation, but extrapolation definitely was. Now, extrapolation is trying to make, or trying to use the prediction equation for an x value that is outside of the set data that you have. So, for example, I'm just making this up right now. Let's just say it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I don't know the concept of this or the context of this problem, but I'm just making this up. If you were to get the prediction equation, which I don't know, let's just pretend it's y equals, 2/3 x plus 1 or some junk like that. I don't know. Making it up as I go along. If you were to plug in an x value for 7, that's fine. 7's very close to the data. But if you were to make a prediction with an x value of like 12 or 20 or 15 or whatever, anything out there, or heaven forbid you did something like -10, that is extrapolation. And extrapolation is to be taken with a grain of salt. Extrapolation is not something that can be trusted but it is something that we do regardless. Any scientific model in regards to climate change, for example, is extrapolation because they're trying to figure out values that are way off into the future. But you don't know what's going to happen past the data that you have. The example I use in class is pretend it's the 1980s and I just put all of my money into cassette tapes. Look at the sales of cassette tapes going up and up and up and up and up. It can't go wrong. So you put all your money into cassette tapes because you're going to say, man, by the mid 1990s, I'm going to be a billionaire. You don't know what's going to happen. 1990s, cassette tapes started dying out because CDs came into play. Now CDs are a relic of the past. Extrapolation's risky. It's dicey. But it's basically trying to make a prediction with an X value that is outside of your data set or data range. College Board states that questions aren't heavily dependent on calculators. Jonathan Breton. Yeah, I agree. There's a link in the description called Predictions for the 2020 AP Stat. Go there, and it does give you a good idea as to what this test would be about. And yeah, it's going to be very concept-based. Ivan says, can you go over sampling distributions? Yes. Sampling distributions. I could reuse paper. I'm going to reuse paper. Sampling distributions are mainly focused on... No, let me start it like this. Okay. The sampling distribution chapter, what it is all about is the fundamental theorem of statistics. It is all about the fundamental theorem of statistics. There were a couple main formulas that came out of that chapter. And well, I'll write both of them. So it's like, I'll write these here and then I'll explain what's going on. Obviously, these can be written in slightly different ways, but these are the ways that I am choosing to write them. No, SD. Standard deviation of p hat square root p cube over n. There we go. Okay. Let's just pretend for a moment that the average height of an adult male in the world, the average height of an adult male in the world is like, I don't know, 5'9" or some junk like that. Whatever 5'9" is. Actually, you know, let me just do that real quick. 5'9". I can't do math in my head for some reason. Having a little trouble today. 69 inches. Cool. That would be the accepted population mean. So then you go about collecting a sample, and you take a sample of 100. And another person takes a sample of 100. And another person takes a sample of 100. And a ton of other people keep taking samples of 100 and finding their own individual X bars of the adult male height. Well, if you were to graph them, they would form, because you're taking sample means of 100, if you were to graph all of your sample means, all of your X bars, they would form a normal curve. Something very close to a normal curve. And the accepted mean of that sample distribution would be these 69 inches. That is the population parameter. Now, there is a population parameter for standard deviation. I don't know what that standard deviation is. Let's just say it's 2. I don't know, it's 2. Now, the standard deviation of this sampling distribution would be 2 divided by the square root of the sample size. And that would determine the standard deviation. The whole concept of the sampling distribution had to do with the fundamental theorem of statistics. Basically speaking, that as the sample size grows larger, the distribution of sample means. This would be the distribution of sample means. As the sample size grows larger, the distribution of sample means becomes more and more normal, which is also the central limit theorem. The general concept of, like, okay, if I took a sample of 100 people what are the chances that I would have an X bar of 70 or higher? Okay, well, according to the fundamental theorem of statistics, I can use normal, 70 or higher, with an accepted mean of 69 and a standard deviation of, well, it's going to change now. It's not just going to be 2. It's going to be 2 over the square root of the sample size. And that would give me the chance that I would find a sample mean of 70 or higher, given all of those parameters. Same thing with proportions. Population parameter, the mean would be your p, and your standard deviation would now be square root pq over n. Do we round down the degrees of freedom for critical value? I doubt very highly that you are going to have to calculate an exact degrees of freedom. The only time that I can foresee that happening is with a 2-sample t-test. That's where I can see calculating degrees of freedom. Otherwise, it's just n-1. If you're doing a regular t-test, degrees of freedom is n-1. If you're doing an interval, n-1. If you're doing inverse t, it's n-1. The only time it's not n-1 is if you were doing chi-squared, some chi-squared test, or some hypothesis test for linear regression, which those are not on this test. So I wouldn't worry about rounding down degrees of freedom. I doubt that they're going to have you calculate something like that. Could you go over confidence intervals next? Could you be more specific about confidence intervals? Like, what type of confidence interval? Are you talking proportions? Or are you talking means? Are you talking z? Or are you talking t? Which one you talking about? Proportions and means. Okay. Sorry. That just caught me off guard a little bit. Made me laugh. Okay. The nuts and bolts of confidence intervals, and I'll go back. I talked about this a little bit earlier. I'm just going to literally, instead of rewriting something, I'm going to put up what I put up earlier. And again, I'm probably going to be on for another 5-10 minutes or so. I mean, again, your test at 2, you need to be logged on beforehand. You need to make sure everything's working. Make sure everything's working with plenty of time to go. I'm not going to take you guys away from that, but anyway, here's one thing we did earlier. Just in general, somebody asked, one of my students asked, confidence interval versus confidence level. And for a confidence interval, you would say, now this is for proportions, but obviously this also applies to means. But for confidence interval, you could say that I'm 95% confident that this interval has captured the true proportion. Whereas, if you have to interpret the confidence level, you would say something along the lines of, well, if this sample were repeated many times, if I did the sample and then somebody else did the sample and then 100 other people did the sample, and they all made their own intervals, 95% of those intervals would capture the true proportion, and 5% would not. And we're just honestly hoping that we are within the 95%. We are 95% confident. We are not saying there's a 95% chance. No. You are saying you are 95% confident that your interval did what it was supposed to do, that it actually captured the true proportion. Just saying. Now, going further than that, same thing with these calculations right here. These are for means. I know we asked for proportions and means, but these are the means right here, whether you're doing a z-test or a t-test. Whether you have the population standard deviation or you don't have the population standard deviation determines if you do z or t. But yeah, it would fall under the same concept of interpretation. Now again, this test that you're taking today is going to be concept-based more heavily than calculation-based. One of my students asked earlier about calculating a margin of error both with and without the graphing calculator. That's what I have right here, where I showed them how, well, if the confidence interval were calculated or given to you, you could calculate the margin of error by finding, oh, there's the midpoint of my interval. From the upper limit down to the midpoint was about 17.9% margin of error. Or you could take the range of lower to higher, divide it by 2, you get the same thing. Or you can calculate it by hand, you get the same thing. So, for you guys that are hanging out right now, again, if you have any other questions, please type them in the chat. If you check out the links in my description below, I have some things that may be helpful to you. I have a PDF of a video that I did. It's like 8 pages long or something like that, of key concepts and formulas. Matt Bogner, he is a professor at the University of Iowa. Very nice guy. He has a website that has binomial and geometric distributions and inferences for means and proportions, which are very helpful. AP checklist, then predictions for the 2020 AP Stat test. No, I will not be staying live during the test. That would be unethical. That would be very unethical. For you guys that are in the chat right now, I do, other videos. I know you're just kidding. I know. I do other videos besides math-related videos. I do AP Stat stuff. I do video game stuff. I do whatever, just fun, stupid stuff. Ethic schmethic. We can do this together. John, you know the deal. You know what? I'm gonna do something hopefully a little special for you guys. I'm gonna print out the AP Stat prayer, and I'm going to recite it to you in a sign of solidarity. Let me just print this thing out, and I'll zoom it in on the camera after I print it out. Hopefully it'll print out properly. The AP Stat prayer, which I posted the link in the chat a while ago, but I'll do it again in a moment. Why would this thing print? There it goes. It's actually trying to print now. This AP Stat prayer was written 4 years ago by a wonderful student that I had by the name of John Herashinsky. He has gone on to college. He's majoring in political science. He's an unbelievably smart kid. History, something like that. I don't know. He's going to be a politician, and I will gladly vote for him one day. But he wrote this. And that year was a very special year for me. That was actually the first year that I taught AP Stat. And I just wanted to share this with you. It's on my Twitter page. But he wrote this. And I will include, again, the link in the description. Copy. Or not in the description, in the chat. And I'm going to recite this to you as he would. Because, again, he's just a really nice guy. But the way that he wrote it, and he recited this before every test and quiz we took in class, and they all recited it together as a group before the actual AP Stat test, and I found that it's very helpful. AP Statistics God, who art in quartile, hallowed be thy sampling. The linear regression shall be done, always with diagnostics on. Give us this day our normal distribution, and forgive us our rounding error, as we forgive those who don't know probability. Lead us not into extrapolation, but deliver us from bias. Median. I've always loved this prayer that he did, and every year on the day of the AP Stat test, I always post it, just as a fun reminder as to the what you guys are about to get into. But you guys, those who are still listening in the chat, both my students I am here for a last minute prayer. Jacob, I literally just read the prayer. Did you not? Were you not here for it? Oh my gosh. That's funny, dude. But anyway, let me do my speech because I want to do a speech before you guys head out and I close this stream. Um, this crop of students taking the AP Stat test today, you are in uncharted waters. This has never been done before for an AP statistics test. And it's not fair that you guys have to go through this, but these are the circumstances that are in front of us. And I know that this chat right now, the people that are watching right now, I know that a bunch of you are my students. I know that a bunch of you are not my students. I wish I could speak to all 200,000 of you taking the test today. But you... I don't even know how to put this. To go through this life-changing experience and to still want to achieve well in terms of AP statistics, that is remarkable, and I applaud you. And I thank you for your dedication, and I thank you for the effort that you guys are about to put forth. I tweeted a few weeks ago all of the graduation booklets that I've gotten over the years. But this year will be remembered for a long, long time, you know. And I do see Alexi, I do see a page, and I got it right here. Let me zoom back out a little. There is the AP Stat Tier Cup. This is the actual one. I took it with me when they locked down the school. I made sure I took it home with me. And I look at it every day. And it makes me smile. You know, I use it for coins now. You can see on the inside. Because I go through coin rolls for fun. And but that's what I have it for. So, but I'm going to hold on to that for quite some time. When we eventually are able to go back to school, I'm going to bring it back to my classroom and I'll put it in a special place. But yeah, I wish you guys good luck. It's 1:35. You need to make sure that you're logged on. You need to make sure that everything's good to go. You need to make sure everything is good. Take a breath. Don't try cramming all the way up until the timer goes off. Don't do that. Cramming until the timer goes off is not going to be good for you. Yeah. I don't know what else to say other than make sure you like this video and subscribe and click the notification bell because I do videos other than math. I do math videos. I do video game speedrunning videos. I was planning on doing a speed run of a video game possibly tonight around like 8 o'clock or something like that. So if you have those notifications on, you'll see that. I do retro, old school Nintendo games and stuff like that. Jacob, you better be there. And if you're not, ooh, you know what's going to happen if you're not. You know what's going to happen. -5. Jacob, right now, I've been in the middle of speedrunning Mike Tyson's Punch-Out. It's a pretty solid game. I don't know. I could run other things. I could run the original Mario. I've been trying to speedrun Contra. I still have a lot of work to do on that. But we'll see what happens. I could also speedrun Mario 3. I could speedrun a lot of stuff, but I think I might do Mike Tyson's Punch-Out tonight. Mainly it's for the chat. I'd go into the chat, you know, I'd be doing it and I could converse with the chat. And you're getting me off topic, Jacob. You know what? I'm going to put Double Dragon on the list. I have a list of games that I'm looking to get into. One of them was Castlevania. And Double Dragon I'll have to put on the list. So it's time for my grandmother to pick up quartz and valuable onyx jewels since 16. Yes, it is. Yes, it is. And guys, just remember one thing. Oh, I was about to say that. Nice. Just remember one thing. If the P is low, I'm gonna let you fill in the blank right there. If the P is low. Good luck, guys. Good luck. Good luck. Good luck. And I'll see you on the other side. All right, signing off.